So if a list is just a series of items, each item in that series can be used like a variable of that type because it is just a variable of that type. So for example, if you have a function that's expecting, a string for some purpose, whatever. So it's going to accept a string of some purpose. I don't know what it's going to do with it. So that had better be a string or else the program will crash because you can't add a number to a string in this language. So when we were ready to call it, if we had a list that looked like this, Bob, Dan, and Sue, then when we called D, we could pass in any one of these values. Now, if we passed in the list as a whole, that wouldn't work. I don't think it would. I don't think its results would be anything like we would hope for anyways. But if we passed in L subscript 0, since that's a string, it works perfectly to fill this string in. And it would print hello Bob. And then, if you called in D L subscript -1, -1 means the last element of the list. And so at that point, it will print Sue. What if you have a string that's just a series of values and you want it split into a list? That might actually be worth doing in idle. I believe we're on Lecture P.
Yeah. Did you start the recording?
I did. Thank you so much. Alrighty. So, Lecture P. We're still talking about lists. Starting on page. I ought to do more of that. But anyways, Chapter 5, page 10 is where we are. Okay, so say we had a string that looked like this. It was a series of values separated by something. Commas, tabs, who knows what. So Bob, Sue, and Dan, like that. But we wanted to turn that into a list. That's what the split function is for. List equals split, parentheses, S, comma. We have to say what the delimiter is. The delimiter are these commas. If we had separated these with something else, like spaces, we'd put a space there instead. And then we could print our list out just to make sure it really is a list.
You have to have commas in between?
I took the commas out because I told split to accept to expect spaces. If I use commas here, I better put a comma there. If I use spaces there, I better put spaces there. If I use tabs here, I better put \t there. Very good question. Yeah, normally I would put commas there. I just changed it to space and didn't change it back. So I run it, and what do you know? Split is not defined. My mistake. Split is a method. This needs to be s.split. It's not a function. It's not a built-in function. So I needed to prefix it with s dot, and I needed to take the s comma out from there. There, and there's our list. And we could do anything with those values that we needed to. That's useful stuff, because when you read in a file, it comes in as text. And if you want that text to be in a list, you're probably going to wind up calling .split. So if you had a list of numbers separated by commas, that'd be real important to know. Let's do that. Here's what our string is going to look like now. Just put some numbers in, and I know we've done this a little bit now, but we're officially on the list chapter now. Just type in some numbers separated by commas. Doesn't matter what the numbers are. Please don't type in my exact numbers. L equals S dot split. This time we're splitting by commas. So quote, comma, end quote, in parentheses. And print that list out. All right, and there they are in a nice handy list. Since they're a list, I can calculate their sum and their average or whatever, right? Total equals the sum, parentheses L, in parentheses. Average equals sum, parentheses L. How do I determine how long that list is? I use the len function, because that's what average is, right? It's the total divided by the number that you added. So sum, parentheses L, in parentheses, divided by the length of the list, len, parentheses L, in parentheses. And what do you know? It goofed up. Why? Because this is not a list of numbers. It's a list of strings. And this is where it's suddenly going to look a little bit like voodoo, because the fastest way to convert it is to use what's known as list comprehension, which I've mentioned once or twice. A slower way to do it would be to write a loop that will convert from one format to another. We may as well do that just because it's educational. After I do it this time, I probably will always use list comprehension. But for this to work, it must be a list of numbers. That's our problem, and it's not yet. Right now, L is a list of strings because that's what it was when it started. Right? It was a string, it got split up, it's still strings. So here's what we're going to do. We're going to make a list that goes through all these items, converts each item to a float, and then adds that to another list. So let's do it. So I'm going to declare a new list that's going to contain our new values. Maybe I'll just call it NL for new list, or list of numbers, or something like that. It's an empty list so that we can start adding things to it. So those are square braces with nothing between it. Then for value NL colon, for every value in that list, value equals float parentheses value in parentheses, and then add that to the list. NL plus equals value, or NL dot append, I believe. Either way works, unless it's dot add. I never can remember. Looks like it worked. Okay. So this converts. We need to convert our list of strings to make a list of numbers. Let's do it with a loop. If we didn't mind destroying the original list, we could write a for loop that was an index-based for loop, subscript-based for loop, and then replace the values as we went through. Or we could convert each element and put them back into the same list using a for index, which on Tuesday, for some reason, I was calling them for subscript. Interchangeable terms. So, for I in range, parentheses, len, parentheses L, because it's got to go through the whole list. L subscript I equals float parentheses L subscript I in parentheses. See, that's shorter. I almost kind of like that. I think I'll remember that. That's almost as if, yeah, I really am digging that. That may replace list comprehension as one of my favorite ways of doing conversions on a list. That is so cool. Okay, I'll show you how to do list comprehension as well, since I keep talking about it. List comprehension is when you do something like this. L equals, and then you put the square braces there, and you put a whole little for loop right inside the square braces. Or use list comprehension. And that would look like this. And it does the same thing this does, really. L equals square brace, float parentheses value in parentheses for value in L in square brace. So what this means is, it's like a for loop. For every value in list, turn it into a float and store that result back in the list. And I better slow down and make sure that we've all had a chance to catch up in typing. I'm going to remove this comment because it no longer is a list of strings. So I'm going to take that comment out. It still has to be a list of numbers, but I don't know if that's necessary to have there anymore either, so I'm going to remove that comment. And I'm sure I've talked a big game. Let's run it and make sure I don't have any syntax errors. Yeah, I didn't print out the total and the average, but I'm sure that it calculated them. And so my next statement should be to print the total and the average. One more line of code. Print parentheses quote total equals percent F comma average equals percent F end quote percent sign and open parentheses and two closed parentheses, and inside those parentheses we're going to put the two variables we want to fill in these placeholders, which are total and AVG. Total comma AVG. And I have no idea if those are really the total and the average, but I have no reason to suspect otherwise. So list comprehension is nice because if you ever need to run a series of functions on a series of values, you can set it up like that. Like, do you remember our function up here? No, I guess it was in our just in our notes over here. I'm going to talk about that. Let's blaze on. So, different methods that you can do with lists. You can append to them. You can extend them. I don't really see any reason to do that because you could also just do plus equals on that. But if you want to add one list to another, you use .extend. You can insert into a list. You can do what's known as a pop, which removes and returns an element from a list. What does that mean? Let's make a list and we're going to pop a value off of it. Colors equals square brace, and just type in 3 colors. Red, end quote, comma, quote, green, end quote, comma, quote, blue, end quote, in parentheses. Now we're going to pop the last one off. By default, if you call pop, it removes it from the last one. You may wonder why. It involves older programming technique called stacks, where you could push things onto a stack and pop things off the stack, and it always worked on the end. So that kind of got preserved as a legacy concept. If we do this, S equals colors.pop, parentheses in parentheses. If we print out the colors list, the last one's going to be gone. And if we print out S, it's going to equal blue. So print, parentheses, quote, S equals, end quote, comma, S. And then let's just print out the list, right? Print, parentheses, quote, colors equals, end quote, comma, colors. And so after that pop's done, we're going to see that the list now just equals red and green, and S equals the color, the item, the element that was removed from the list.
Is that from DOS?
I don't think DOS has a pop command, but yeah, it's old school. The terminology is very old school, so I'm not surprised you've heard it before.
So pop just takes off whatever that last string.
Yeah, yeah. Or you can pop a different one if you pass in an index. Like what if you want to pop the first one out? Well, if we type in pop 0, comma, let me make sure that that's the case. Yeah. Yeah, so if we do S equals colors.pop parentheses 0, it's going to pop the first one. Whereas in the meantime, this popped the last one. Which I guess you could have done just by doing pop -1, right? That also means the last one, but not going to mess with that. And I'm just going to copy these 2 lines of code and paste them again. There we go. Right, our list only has 1 element in it now. What happens if we call pop 2 more times? Well, it's only got 1 more element in it. So the second time we call pop, it ought to blow up. Let's just prove that. Colors.pop, that takes one of them off. Colors.pop, that's going to take the other one off. And that should cause a crash. We're popping from an empty list. So you should check to see if the list is empty before you pop from it. How would you do that? You could just use the len function. So if we wanted to, I'm going to comment this out, would crash because list is now empty. We could use len, parentheses colors, to make sure list is not empty. Like this. If len, parentheses colors, in parentheses, greater than 0, colon, print, parentheses, quote, popping 1 more time, end quote, in parentheses, and sure, why not, colors.pop. But that is not the case unless we went and added more detail, added more data. So else, colon, print, list is empty, nothing to pop, end quote, in parentheses. And there we go. The exam had a question about try and except. Since popping can cause an exception, we could capture that exception. We could trap that exception like this. Try this code, please. So try colon, colors.pop, parentheses in parentheses. But if it blows up, except colon, print, boom, list was empty, in parentheses, in colon, in parentheses. And we're definitely going to see that message. because the list is empty. But what if the list wasn't empty? What if right before that try, and I know always messes people up when I go and edit stuff above, but I'm inserting something above try now, colors dot, or why not just do colors plus equals, and then let's add another color, silver, end quote. Now I'm going to do it the way the book does it. Colors dot append, parentheses, quote, silver, end quote, in parentheses. Now we're not going to see the message boom list was empty. Let's put one more pop statement in here. Excuse me, one more print statement. I'm changing this last colors.pop to say s equals colors.pop, and then print parentheses quote popped end quote comma s in parentheses. All right. Now, is popping the most important thing in the world? Is it why I spent the last 5 minutes talking about it? No. But whenever you use an index number, if you give it an invalid index number, it's going to crash. So that's why I've been talking about techniques for avoiding that. Try except is one way to avoid that.
You're messing with my eyes, moving that around like that.
Sorry, this is at the bottom now. So of our methods for manipulating them, we've seen pop index, we've seen insert before. We saw insert last time where you can insert something into the beginning of the list. Pretty sure we did. Did we use dot insert last time? I could make sure. Yes, right there, bigger in life. Right, so dot append adds something to the end of the list. Dot insert sticks it into the beginning of the list or whatever position you specify. If I said 2, then 900 would become the new second value of the list. Third.
Real quick question.
Yes, sir.
When appending, we got color dot append silver.
Uh-huh.
What if we wanted to add 2 colors instead of 1? Will we just leave it? Will we put a comma?
No, that's what this, very good question. And then the question is, what if we wanted to add more than one element to it? Would we use dot append and put things between commas? No, you would actually use extend. If we needed to add 2 things to it rather than just one,
Am I getting that?
colors, nope, not at all. We're right on that slide. Extend the list by these things. Right? Orange, end quote, comma, quote,
Okay.
gold, end quote, end brace, end semicolon. Like that. And so now the list has got those things added to it. I'm just going to copy and paste that statement so that we get those things in there twice so that I can print them out and make sure that I like the way they look. So I'm just copying that. Please don't type in the second line if you have the option of copying it, and then print colors one more time. I'm doing that because I want to see it say orange, gold, orange, gold. And it does. Or I could have done this. I think. No, I'm not going to mess with it. I'm not sure it's going to work. Yeah, I got to find out. Colors plus equals X in quote comma Y. I don't think this is going to work. That's why I'm not bothering putting in real good data there. And then if I print that out, what's it look like? It worked. Okay. So if you wanted to add multiple items to a list, you could do it that way as well. So the append method expects a new element and adds it to the end of the list. The extend method does the same thing, but adds the list argument to the end of the list. And if it's a whole list, which it would be, then it adds the new list to the old one. Pop removes a specific element at a specific position. Searching for a list. You can check to see if something is in a list using the IN keyword. Do I have the color gold in my list? If, quote, gold, end quote, in colors, colon, print parentheses, yes, comma, gold, end quote, in parentheses, else, colon, print, no gold. And of course it's going to print yes, just because I remember doing that right there. What if you wanted to find out its position? You can do that. You can search the list and find out its index. Or you could delete that element. Now there's two different keywords for deleting from a list, and I don't ever remember until I look at it which one does which, so I'm not going to jump ahead and do it without seeing it on the PowerPoint first. One is delete and one is remove. Sorting a list. It's pretty neat to be able to sort a list. Like if we have a list of colors and we wanted them sorted alphabetically. Colors.sort, parentheses in parentheses, and then print that list out. Print parentheses colors. And there they are. Gold, gold, orange, orange, X, Y. The fact that we have X and Y in there is kind of stupid. Let's replace those with real colors. Colors.replace, parentheses, quote, X, end quote, comma. Well, what are we going to put in there? Put another color in there. Violet, end quote, in parentheses. Or it'll blow up. What do you know? Pardon me. Replace list Python. I guess I'm thinking of strings. I know you can do it with strings. They're wanting us to use list comprehension and all sorts of fancy things. You would think it'd be easier than that. Okay, fine. It's not so easy. Delete that. Did not work. Works with strings though. I'll prove it. S equals hello, end quote, and then S equals S dot replace, parentheses, quote, lowercase l, end quote, comma, with W, end quote. And then when we print S, it's going to print out hello, print parentheses S. There we go. Now lists and strings are so similar that I thought that the list function would replace, that it had the list function, that it had a replace method. It does not. Good. For a horrifying moment, I thought it had been paused for 10 minutes. So mutator methods and the value none. All of the functions and methods return a value that the caller can then use to complete its work. Some of these things usually return no value of interest to the caller. And so if you store its return value, it's going to say none. Well, we almost never worry about the none return value, but we can see it real easily. Write a function, I don't care what it's called, define silly, parentheses in parentheses, colon, and all it does is print silly. Print parentheses, quote, silly, end quote, in parentheses. Now back tab and do R equals silly, and then print out R. So R equals silly, parentheses, in parentheses, and then print parentheses R in parentheses. We're going to see that R equals the word none. It's equal to the keyword none, the value none. It's not a string with none in it. We're not going to see any quotes like that. So all it means is that those methods are defined without returning a value. If I returned anything, like if I return 0, it's not going to print none anymore. It's going to print 0.
Simply because you said return.
Exactly. So any function that doesn't return a value returns none instead. And really the only reason I'm talking about it is because it was on the slide, because I don't take advantage of that. I suppose you could, right? Like if it returned a good value, great, it returned an int or whatever, or a string. But if the function failed, then maybe it returns none instead, and you could check that. Maybe the next PowerPoint has a great reason why we care about that. But I don't think so. So aliasing. What does aliasing mean? It means you have two pointers to the same list. Right, I had something called colors. I'm going to make a new list called flavors, but I'm going to point it to the colors list. Or nah, that's stupid. How about hues? We're going to be all fancy. Hues equals colors. Now we have two words that mean the same list. That did not make a copy of the colors list. If we change hues, the colors list is going to be changed as well. So for example, if we pop something off of hues, or if we change the first element or something, hues subscript 0 in subscript equals, I don't know, some color we haven't used yet, pink, end quote. And then we print parentheses colors. We're going to see that the first element of the colors list is pink. It's just like you have two street signs pointing to the same street. It's the same street. So you can get to it by one street sign called colors, or you can get to it by the other street sign called hues, but it's still the same street. So if you go and you paint one of the houses pink, both street signs are pointing to a pink house. So when I run it, I should see that the colors list has been modified so that the first element is pink. And in fact it is. Even though we didn't say colors subscript 0 is pink, we said hues subscript. That's called an alias. Hues is an alias to the colors list, meaning that any changes to the list using hues actually changes the colors list. And vice versa. If you change colors, if you set color subscript 1 equal to black, then when you print out the hues list, the second one's going to equal black.
Did you mean to have on alias start a single quote and end with the
No, that was dumb. There we go. I can't type. Finally, got it. So, colors subscript 1 in subscript is equal to quote black, end quote. And so if we print hues, we're going to see that its second element has now been changed. Again, it's just two things by the same name. You call me Jeff or you call me Professor Thompson. If you break my glasses, then both Jeff and Professor Thompson's glasses are broken. And we see that. We changed colors subscript 1, and when we printed it, hues subscript 1 is now equal to black.
replace the W, like the L with the W, and I use a different Y. And then every time I print it.
Make a lie out of me.
I mean, but yours work, it's
Right.
not word.
Deb, did replace L with W work on yours?
Yes, sir.
Is that perhaps a 1 and not an L?
Oh, it is one. I thought it was one.
Looks the same. Let's run it. That's what it was.
Okay, okay, thank you.
Okay, yeah.
So I did the same
So on
See,
your
if
dot
somebody else
replace
look at
call,
it.
make sure that it's a 1.
Oh, I did.
You did,
it
you
when-
fixed that, good deal.
It's like I have to check.
I
It's
try
correct. It's clear.
to avoid lowercase l just for that reason, but I didn't that time. Just like uppercase O, try to avoid that. Ooh, and I left the recorder going while I did that. Identity and structural equivalence. Programmers might need to see whether two variables refer to the same exact object. How do we know if those lists are equal or point to the same thing? So equal returns true if the variables are aliases for the same object. If we do if colors equals hue, it's going to print true. But it will also print true if the contents are the same. So equal has no way of distinguishing between what it's doing, whether it's checking to see if we have two aliases or whether we have two lists with the same contents. And those are two very different ideas, right? You only have one Professor Thompson even if I have two names. But if you clone me and you compare them, then it's still equal. It's still going to say true. And so you use is to check to see if they are the same. If hues is colors, print yes, hues is colors. That's bad English, but let's roll with it. Now we've had other lists along the way, like capital L. If colors is L:, and that's definitely not true. So print whatever, yes, end quote. I'm just putting something there because I know it's not true. Else print no, comma, colors is not L. And so I'm going to add a comment here as to what's going on. Test object identity. Are the two variables aliases of the same data? I can't think of a time when I've used that keyword other than to teach about it. So yes, hues is colors because they're aliases of each other, but no, colors is not L. L was that list of numbers or whatever we made it. So comment, use the is, well that looks cool, but it's not what I wanted, quote, is, end quote, to check to see if two variables are the same variable and not just the same date value. To test value, of course, you use equals. Subtle difference. Like I said, out of about 5 years of using Python, I can't think of a single time I did that. All right, here we go. To find the median of a set of numbers. They give a lot of code here. Well, read the file in. Our numbers is in a file. So they read the whole file in and then convert each number into a float. And then they sort it. And then they get the median. They divide the length of it by 2. And the median just means the middle object of the list. Like we have a list of colors. What is the median of our list of colors? Get median of list. So midpoint equals the length of the list divided by 2. Now to me, that could wind up with a fractional value, right? Like 4.5 or something like that. So I bet we need to change it into an int, even though I don't think that code showed that. Maybe it did. Yeah. See, they're not.
Instead of a float, we want to make
Oh, they're doing floor division, so it definitely rounds it down.
Okay.
Okay, so the midpoint of colors list, floor division by 2. So divide by 2 and round down. And then the median equals the colors list at the midpoint. Now that's not too hard of a thing to do. But calculating the mode, the one that occurs the most often, is challenging. You have to use a completely different data structure in order to do that. You have to create a dictionary, run through the list, updating the dictionary for every element in the list, and then pick the one with the highest value. That's a lot of trouble to go through just to get the mode of a list, the word that occurs the most often. You can use a statistics library to do it in one line. So in programming problem 5.1, it wants you to calculate the median, the mode, and the mean. Mean just means average of a list, and they're expecting you to write 20 lines of code that you copy out of the book, and yet you can get the mode with one line. So I'd rather teach to that. Let's make a new list. That's just a series of numbers, but make sure that some numbers appear twice. Like I'm going to put like 7 or 8 sevens in a row. They don't even all have to be in the same order, right? But I've definitely made 7 occur more often than anything else. So mode means the value that occurs most often in a set or a list. Easy way to get it. Import statistics. Value or n or something like that, or md. I don't want to use the whole word mode. I probably could get away with it. It doesn't turn purple when I type it. So mode is equal to statistics.mode, parentheses in parentheses, passing in our list. So capital L between those two parentheses. And let's print it out. Print list in parentheses. And on the next line, print parentheses quote mode of L is end quote comma mode. And as expected, since I have more 7s than anything else, it's going to return 7. Now here I thought I had orange gold, What's the mode of this list going to be?
Orange?
Yeah. I never did print out the median of that list that I just calculated, but I guess I could. Right? I never printed the median. So I'm going to come back up here under where I calculate median and just print parentheses, quote, median of colors list is, end quote, comma, median. I don't think the statistics library called median, the function called median in the statistics library would support a list of strings like that, because statistics are numbers. And so the median color is orange because the middle color is orange. Close enough, right? There's 6 values. It had to pick one of the 2. It went with that one, I'm sure. All right. So this code shows opening a file, reading it in, converting all that text to numbers to make a list. Well, let's play with that. Let's make a new file that's a list of numbers. So I'm going to do new file, and it's just going to be numbers separated by commas.
Random?
Yeah. That's probably about enough. I'm going to save it, and I got to give it a name. That's pretty awesome. So how about data underscore n or p? This is lecture P, right? Data underscore p dot txt.
What we save it as?
I called it lecture underscore p because, or excuse me, data underscore p because we're on lecture P.
Roger.
Now we're going to open that file and read those numbers in, convert them to lists, and calculate the average of each line. So we're going to read something in. We're going to call split to turn it into a list. Then we have to turn it into a series of numbers. We could use list comprehension for that, or that for loop. And then we're going to call sum to get the sum of each line. Sounds complicated, but we can do it like in 5 minutes. It's not going to take too much. So let's open the file, or let's get the file name. The file name is equal to quote, and if you called it the same thing I did, data underscore p dot py, end quote. Now file equals open parentheses fn comma quote r. We're opening a file for reading, end quote, in parentheses. Now we're going to need a for loop that processes that file.
Question.
Yes, sir.
Did you save it as a text file or as a...
I actually just saved it as a py file. If you saved it as a text file, then change that extension right there.
Okay, got it.
Yeah. Yeah, so if when you did your save as of that file, your numbers file, if you did save as and called it a .txt file, looks like I did call it .txt. So that's not going to work. Just make sure that that matches that. My mistake. Okay, so I'm going to change that to .txt. You'll be able to tell real quickly whether that worked or not. In fact, I'm just going to run it now to make sure. Okay, it didn't blow up. Okay, so we're going to use a for loop to read through it. So for line in file colon, for every line in that file, let's split it. Line equals line dot split parentheses quote comma end quote in parentheses. Let's print that line out just to make sure that we like what we're seeing before we go any further. See, make sure that there's nothing unexpected going on, because I think that there may be. Yeah, there's these backslash n's. Those would mess us up. Does anybody remember what we have to do if we're reading from a file and we're getting like new lines or spaces at the end of each line? There's a command that handles that. It's strip. line.strip. I think that's going to do it. Nope. Line equals line.strip. Line equals line.strip. Yep, that got rid of our \ns. Strip just removes any so-called white space at the end of the string or the beginning of the string. White space being tabs or carriage returns. So now, when it called split, it turned it into a list of strings, but just like up above, it's a list of strings when we want a list of numbers. So, line equals, we're going to use list comprehension. Pair of braces. Inside there, float parentheses value in parentheses for value in line. So now if we print the line out, we're going to see that it's a list of numbers. And that's what we're seeing, right? Changes it from a list of strings to a list of numbers. Now we can do math on it. Total equals sum of that line. Average equals total divided by the length of that line. So LE in parentheses, line in parentheses. Let's comment out these print statements. And then let's print the line, comma, total equals %f space average equals %f, end quote, %, an open parentheses, a closed parentheses, and a closed parentheses. And between those two parentheses, let's put the variables that are going to fill in those placeholders, which are total, comma, average. And there we go. Right, it's not pretty, but we see what it's doing, right? It's adding up those numbers. That's the total of it, and that's the average of it. Now what their code did is it created a list that was the sum of all of this stuff, right? That had every number in it. And we could have done that as well. If we wanted to add up every single line in our list, we could have done that. Let's do that and just call it all. So above the for statement, I'm adding something new here, so I'm going to mark it off with hashtags or something. All underscore data equals a pair of square braces. We're going to make an empty list. I just added that. And then down here, or at least after the list comprehension, right here, I'm adding something here too, so I'm also going to mark it with a whole bunch of hashes. All underscore data dot extend parentheses line. Append that one list to our all data list. So these are the two lines that I just added. And when you're typing this stuff in, don't put all those hashtags. That's just for, you know. So at the bottom of this, we need to close the file. So file.close, parentheses in parentheses. And just for fun, let's print all data. Or let's get the sum of all data. Total equals sum, parentheses, all underscore data. And then print parentheses quote, sum of all data in file equals, end quote, comma, total. We can calculate the average too. You know how to do that. Average is equal to total divided by the length of the all data list. There. So if we added up all the numbers hopefully they would add up to 681. So what is all data? All data will be a list that contains every element in every line of our data file. You may not want to process it that way. And honestly, there's a much faster way of doing that. If you call .read, it returns a string that has every single element, every piece of data in the file. So you don't need a for loop to handle it if you're just calling .read. So I would disagree with the way the book implemented it, except you don't really want to call .read if the file is several megabytes long, because you don't want to read it all in at once. It's better to read it in line by line. So the way we did it is actually better. Guess I won't quibble with the book. So that's what this does. Opens up the file, reads it line by line, converts the line. Well, first it strips it, then it splits it. What happens if there's a problem with our data? What if my data, and I'm not sure if this is going to work, what if I had a blank line in here? I'm going to add a blank line. I don't recommend that you do. But when I run it, it crashes. We could fix that by checking to see if the list was empty. After we've made the list, we could just do if list dot or if len list greater than 0. Do this stuff. Not a bad thing to do. I'm going to add a comment to that effect. We should make sure list is not empty at this point. We're skipping that, but we should. All right, I think that's about enough for today. Homework for this is going to be pretty short. Write code that 1 creates a string of numbers separated by commas. 2 uses .split to turn that string into a list named nums. 3 uses a loop or list comprehension. We've done it several different ways to convert that list into a list of floats, because at this point this is a list of strings. 4, print the list using a for loop. 5, calculate the sum and the average. Calculate the total and the average of the list, of the nums list. I'm not going to even specify the variable name. And why not? 6, use statistics.mode to get the mode of the list and print, display it. There's also statistics.median and statistics.mean. But since I didn't mention it, I won't put them in there if you feel like it. If you feel like adding those 2 lines of code in there, you could also print out the mean and the median. Now the mean is just a synonym for average. So if you call .statistics.mean, you'd get the same value. Make sense, gang? There's a Dropbox already, so feel free to go ahead and upload it. And let me print this out. I know at least one person would like a printout of it.